Hello everyone, welcome to webology.in. I'm Aakash Biswas. This is C Programming Lesson 2. In the previous video, in Lesson 1, we have seen that C is a compiled language. Now you may be wondering what's a compiled language and what should I know about compiled languages? Is it necessary to know about compiled languages? And if you know about compiled languages, then you also might have heard the term interpreted languages. And if you haven't heard, we'll have a look. So let's find out what's a compiled language. A compiled language is a programming language whose source code is translated into machine code by a compiler. It's basically a software or translator that generates machine code from source code. So when you write the source code, which is in an English-like format, like we have seen in the previous video in lesson 1, hash include int main printf \n return 0 etc. This is known as a source code, but the computer won't understand anything other than ones and zeros because the computer only understands binary code. So therefore you need a compiler, or rather than translator, to translate your source code into machine code, right? So that the computer understands that and gives you an output. So here is an example of compiled languages: C, C++, Java, and Objective-C. Now these are just a few examples I've taken. The most famous programming languages, technologies, and compiled languages. I also put in a link in the description below, and you can read more about compiled languages and know more about compiled languages and a complete list on compiled languages. Now let's move on to interpreted language. An interpreted language directly executes the source code line by line. Okay, the source code does not have to be compiled in order to run the program. So what's the difference? Well, basically, interpreted language, like seeing example are JavaScript, Python, Ruby, PHP, etc. So when you write a line of code, and if you've been following my tutorials, or if you haven't, you know that I have a complete course on JavaScript, which you can find in the link in the description below. And JavaScript is an interpreted language, which means that if you write a line of code, say alert, then bracket, then inside that semicolon hello, and you run that on the browser, you'll see that it'll give you a pop-up box, right? So there are many different functions and many different commands that you can use. So when you write a complete JavaScript program, each line will be executed as the program runs. Okay, so it doesn't have to be pre-compiled or compiled. It directly executes, and what does the execution is your browser. Okay, so here's some of the steps taken by interpreted languages. First, parse the source code and perform its behavior directly. Parse means to understand the symbols and the logic of a program, say be it JavaScript program or PHP program. Okay, then 2, translate source code into some efficient intermediate representation and immediately execute the code. Okay, as I've told you, you have a line of code in JavaScript, you'll execute each code line by line, okay, and as it goes from top to bottom. And lastly, explicitly execute stored pre-compiled code made by compiler, which is part of the interpreter system. Okay, so example of interpreted languages are JavaScript, very famous, Python, very famous, Ruby, which was peak at one point, it's not so much, but it's also used for web development, and PHP. Okay, so this diagram, what is it? Basically, this is the process in C programming. So The edit part is where you write your code, your source code in English like instructions. Okay. Then comes the compiling part. So basically your source code, your English like language code, is translated, okay, into bits and bytes, into binary code, into ones and zeros, which the computer can understand. This will produce then an object file with a .obj extension. Okay. After that, you need to link that object file. Then is a linking process. After linking, it will produce an .exe file which you can open and run the program. So basically, if you want to run, say, a calculator program that adds two numbers, you first write the code in English like language, that's your source code. Then you translate it into machine code, okay, which you create. For that, you need to compile. Then you create an .obj extension file. Now, what can you do with the obj extension file? Can you really understand ones and zeros? Are you such a nerd, such a good nerd? I mean, are you such a big computer scientist that you can understand ones and zeros? Maybe you can, maybe not. And this is why linking is important, because after you link, it will produce an .exe file. Okay, but again, on Dave C++, this process was before that. You need to do edit, then debug, then compile, then link, and then execute. But now it's become quite hassle-free. You can directly edit the file, write your code, compile it, or even compile and run. That will automatically produce an .exe file when you save the program. And lastly is executing, and we can click the .exe file and run our program. Okay. So here are some of the famous programs written in C, and this is basically to give you a certain motivation, a certain feel good factor that when you're learning C programming, basically in this tutorial you'll be learning how to know the syntax and the grammar of C programming. You won't really learn the art and crux of programming, but if you want to do that, then you need to be really good at the basics, right? And what you gain out of learning C program is that you can create amazing software like Windows 10, Excel, okay, very popular spreadsheet software, Git, which is the technology used for GitHub, an open source website that people can upload the source code of the applications, and Linux, another operating system, right? So these are some of the very, very famous software written in C, also including C++ and some other technologies, but C was used extensively. So that is why this slide is to motivate you. Okay. Okay. So now I'll be showing you some of the very basics of programming. The first thing that we're going to start is with variables. We will learn everything about variables, how to declare them, how to assign value to them, and how to print their values. So a variable is basically a storage space that holds data. It can be numbers or even a character. Okay, so let me show you that. Okay, so here this line of code may be gibberish. What is int, what is a, what is the equal sign, and what is 10. So basically int is short for integer. Integer is a data type. Okay, our data type is basically a collection of different forms of data that the computer can understand and relate to. Okay, so an integer, we are going back to very basic mathematics, high school mathematics, is that integer data type can only hold integer values. It cannot hold fractional values. Okay, it can hold both positive and negative integers values, but it cannot hold fractional values. Okay, it can hold 10, -10, -100, but not 1.112. The fractional part will be deleted if we happen to write a fractional value in place of integer data type. Okay, so now I've written this. Let's save and directly compile and run. Hopefully we haven't done any mistake. If we did, then it will give us an error. Okay, there 10 is printed on the console. Why? Because the variable a, this variable whose name is a, I could have given any name. Okay, so there are conventions for the rules for naming a variable. A variable can be alphanumeric, but a variable name cannot start with a letter, with a number. Okay, so suppose I put 1a and I save this file. Okay, let me close this console and now compile it and trying and running it. Error. Why? Let's have a look at the log file. Error, invalid suffix a on integer constant. Okay, expected identifier before numeric constant, a undeclared first use. Each undeclared identifier is reported only once. So basically what it's saying is that the syntax is wrong for declaring a variable. We cannot, as a rule, remember this, we cannot declare a variable name. The first letter of it cannot be a number. Okay, it has to be either a letter or an underscore character. It can also be uppercase or lowercase, that doesn't matter. Okay, but not a number at first. We can put a number later, like A1. Okay, so let's save this and keeping our fingers crossed, let's compile and run this time. There's still a mistake, and why is that? The mistake is here. It's because here int a1 equals 10, but when we are printing the value is still a. The computer won't understand what's the value of a. That is why it's saying a undeclared first use in this function. So printf is a function to output data. So therefore, when we change the name of the variable from a to a1 and we want to print that same variable's value, we need to change that name as well. So let's go ahead and do that. Make it to a1, save it, and keeping our fingers crossed this time, let's compile and run it. In 3, 2, 1, there we go. Haha, 10, right? So this is what you need to remember, that variable names can start only and only with an uppercase or lowercase letter and an underscore symbol and no other symbol. Okay, not a dollar symbol like in PHP, not a asterisk or a exclamation mark, nothing, and not even a number. And variable names are case sensitive. Suppose my variable name is assigned a1 and here I mistakenly put it in uppercase A. Okay, and I want to run my program. I've saved my file and I'll compile and run it, but I'll get an error because let's have a look at here. The log file says that a1 undeclared first use in this function. So variable names are case sensitive. The name that you have declared previously, you need to declare the same variable name here. Okay, then only it'll run. Now int, as I told you, is a data type. Okay, this is the name and this is the assigning value. Okay, not an equality value. There's a difference between assigning a value 10 to the memory location named a1. Okay, so this memory location that I've defined is the variable. It's a variable, and what's its name is a1, and what's its value is 10. And what's this data type is short for integer. Now there are different data types in C, and now we're going to look at the different data types in C and print their values. So let's go ahead. Here I have defined 4 different data types. Int is short for integer. Float, as you can see, can hold fractional values. Similarly, double can hold fractional values, but there's a difference between float and double, is that the fractional value, the number of digits after the fraction, after the dot, is more. Okay, the precision of fractional value in double is more than float. Okay, and lastly, char can hold only a single character. So remember that when you're printing a character, it has to be in single quotes and not double quotes, that is string. In C, there is no concept of string, it's only characters. Okay, now you might have noticed something cryptic over here. Percentage D, percentage F, similarly percentage F and percentage C. So what these are basically known as percentage modifier, and this is used to print the value of static memory. So percentage D will define that the variable A, whose value is an integer, should print only an integer value. Okay, similarly percentage F will only print a float value, a fractional value. Okay, suppose I change this to D, what will happen, you think, guys? Let me know in the comment section below. I'll be really curious to know. Okay, similarly for double, I'm printing a fractional values. The percentage modifier will be percentage F. Similarly for character is percentage C. Now I can add or not add a backslash n, but it's up to me. It won't make much of a difference. Now let's run this program. Let's first compile it and then run it. So there you see 10 the integer value, then 2.34 blah blah blah, that's not important, is a fractional value, float value. Then 1.42.23457 blah 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 is a double value. And why is that? Because precision, the number of digits after the fractional value, is much more than float. Then lastly, we are printing a character, a single character called A. Okay, so this is very important to understand. If you by mistakenly omit the percentage D modifier, what will happen? Let's find out. See, D has been printed, but I want to print the value 10, right? Because the variable a holds the value 10. So anything in double quotes will print a string literal, will print itself. So I can put, as I've shown you in the first video how to print a hello world program, we can print either letters or even numbers, right? Within the string in double quotes. So here you can see 231D. Why? Because within double quotes is a string literal. Whatever you print will literally be printed on the console. But we wanted to print the value of the variable a. So therefore we need to add the percentage symbol and then the modifier, which is d for integer values, right? Similarly, we have done the same thing for the other 4 different data type. For float is f, so remember this, for float is f, for double is f, and for character is c. Okay, so here when we are defining int a equals 10 is also known as static memory allocation. Okay, basically your defining the data of the variable before you're running the program. Int a equals 10 will always be 10, right? How many number of times you run the program? Has it changed? No. Why? Because we have put it as static allocation. We have defined the value before running the program. So remember this. When you are doing static allocation, the value will be defined pre-compilation. It's like before running a program, the value will be given. And what is this cryptic little thing, backslash, double backslash static allocation? This is a symbol for putting a comment. Now there are 2 types of comments in C. One is single line comment with double backslashes, and the other is, let me show you. This is known as a multi-line comment. When you want to write a big comment, say the name of the author of the program, the description of the program, who has written it, when it was written, etc. So there are a couple of uses. So when I run this program, let's run it. What will happen? What is the expected output? Am I the best? Maybe. Let's find out. Oops. What's this? Blank space? Am I the best? Am I really? I don't think so, because that's what printed. So anything that you put inside a comment, be it a multi-line comment or a single line comment, will be ignored by the compiler, right? So let's run this program once again. And I'm still not the best. I'm disappointed because I've commented this string. I put it in comments. So anything between either backslash, asterisk, and this text, and then I'm closing it. Asterisk and backslash is a comment. Similarly, this is a single line comment. When you want to just comment on single line, one line of code, and define what it does. So basically comments are used to define portion of code to fellow programmers, right? When you upload your code on GitHub or you give it to your manager for reviewing it, he or she might look at the program and look at your comments and understand why you are applying certain logic at certain place and certain code at certain place, or even codes, comments are used to debug certain lines of code. Say your program is not running for certain purpose, and then you comment out certain section of code. That code that you comment out will not be run, will not be displayed. So let's have a look at that. Now, the expected output is what? Go home? No, it has to be blank, because printf is commented with double backslashes. Now suppose I remove the backslashes, see, the color has changed. Printf is now a function which will give me an output in string. Okay, so if I compile and run this program, then I am told to go home now. Okay, but we have seen now static allocation, what are comments, what are variables and data types. But will it not be really boring if we define your programs values beforehand? I mean, if you want to make useful programs, say make a simple calculator, a calculator does the addition of two values. How are we going to do that? How? Think. Well, here I am going to show you right now. Now, as you can see here, I have declared three variables of the type integer, but I have not assigned any value. And why is that? Let's save and run our program and find out. Hopefully we haven't done any mistakes and our code goes through. So enter two numbers. Let's put 10 and 20. Our program has closed. You know why? Because I did a very silly mistake. That is, while I'm doing dynamic allocation, I need to put the ampersand symbol. Well guys, no one is perfect, huh? So hopefully now we'll get our console to give us an output, because this is what the program does. It will give us an output, an addition of two numbers, and the result is 30. So this is known as dynamic allocation, where we are inputting data from outside. So that data will be held in the variables A and B. So this is a new function. This is a new command, as you can see. Scanf is like printf, but it's just the opposite. While printf is outputting data, scanf is used to input data, and this is what is known as dynamic allocation. So scanf, then %d. Why is that? Because we are inputting two data, two variables will hold two different data. So the first %d is for A, the variable A, and the second %d is for the variable B. Now, why this ampersand symbol, and why the first time didn't my program run? It's because I didn't put the ampersand symbol. The ampersand symbol is for inputting data. It's for dynamic memory allocation. The data that you put, be it a number or a character, will be stored in the variable a and b. And the next line, what this does is basically the variable c adds the two values of a and b. So in the program, when I run this program and I'm inputting two values, a which is 10 and b which is 20, the result is 30. Why? Because in the variable c, a and b is added, and then printf, the result is %d and c, because we need to put the percentage modifier to tell the computer that it needs to print the value of the variable c. Okay, I hope you have understood. If you haven't understood, or if it's making it's not making sense, or if you have confusions, let me know in the comment section below. Any doubt, just let me know in the comment section below and I'll get back to you. Alright guys, that's it for this video. If you like this video, please make sure to show your support by giving up a thumbs up, right? Make sure to leave your comments. Comment anything. Your queries, your questions, your doubts, your likes. If you like this video or if you disliked it, let me know in the comment section below. I'll be really eager to looking forward to your comments, and I'll get back to your replies. I'll be really looking to reply to your comments. If you have any kinds of comments, please comment below. Guys, if you like this video, make sure to share it with your friends, girlfriends, boyfriends, fellow programmers, non-programmers, your teachers, your neighbors, anyone. Please make sure to share this video. That will help me reach out to more audience and make better and more content. Lastly, do subscribe. Yes, hit that subscribe button now, because if you subscribe, you'll be notified when I upload my next video and you'll stay updated when I upload my next video. Please subscribe now.